video we will see how to solve problems where we're supposed to find the resultant or the net electric field in a system of electric charges in a triangle at the right angle. We have the system. QA is negative 2 microcoulombs, QC is negative 6 microcoulombs. We have to find the net electric field or the resultant field at point P, which is this point located at the right angle. First, we have to identify the direction of each of the electric fields. We cover QC. For QA, which is a negatively charged object, the electric field should converge towards A from all points. So at point B, for the electric field to converge towards A, it should be pointing in this direction. This is EAP. Then, for QC, the same thing. The electric field should be converging towards QC. So from P, it should go this way. We do the calculations. EAP equals KCQA over RAP squared. We replace. KC is constant, 9 times 10 to the power of 9. QA is negative 2 microcoulombs. We convert it to coulombs times 10 to the power of negative 6 over the distance from A to P, which is 3 meters squared. We get this answer. Then we do the calculations for ECP. KCQC over RCP squared. KC is constant, QC is negative 6 microcoulombs. We convert to coulombs times 10 to the power of negative 6 over the distance between them, which is 4 meters squared. We get this answer. Now, to find F net, since they are perpendicular, I'm talking about the vectors EAP and ECP, they are perpendicular to each other. If we draw the resultant or E net, which is a diagonal, it's equal to the diagonal to the other diagonal in this shape. So if I calculated this diagonal, then I will have the magnitude of E net. So this diagonal, if we take it this way, is the hypotenuse in this triangle. So E net is equal to square root of EAP squared plus ECP squared. We replace the values and we get the final answer for the magnitude of E net. We still have to find the direction. The direction of a vector is the reference angle from the positive x front. We measure it counterclockwise. I will consider this angle. So the direction will be tan inverse opposite over adjacent, or this angle is tan inverse opposite over adjacent. The opposite to this angle is this dashed line, the vertical dashed line, which is equal in length to EAP, and the adjacent is ECP. So I replace them, I put their values, and the answer is 30.65 degrees. This is the angle. Now, the direction, since this vector is in quadrant 1, then the direction is this part from the positive x-axis or the positive x front to the vector itself. In this case, it's equal to 0 plus theta, so it's 30.65 degrees from the positive x front. Another system where we have two charges, QA and QC. Both are negative and we have to find the net electric field at point N. So we cover QC. The electric field created by A at point N should be pointing towards A because QA is a negatively charged object. So the electric field should converge or point towards QA because it is negative. So this is EAN. Then we cover A. Same thing for C, since it's negative, then the electric field should be pointing or converging towards C like this. This is ECN. Now we calculate EAN, KCQA over RAN squared. We replace the values. Do not forget to convert from microcoulombs to coulombs times 10 to the power of negative 6. We find the answer. Then ECN, KCQC over RCN squared. We replace the values and we get the answer. Now for E net, same case, since they are perpendicular, we draw the dashed imaginary lines to complete the formal shape of a rectangle where the diagonals are equal. So if this is E net, then this is the same magnitude as E net, this diagonal. So E net is equal to EAN squared plus ECN squared. We replace and we get the answer as 6,104 newtons per coulombs. To find the direction, theta, I took this angle this time. In the previous question we considered this one. I will consider the other one now. So this angle theta, tan, it's equal to tan inverse of opposite, which is this side, the horizontal imaginary line, which is the same as ECN, over the adjacent, which is EAN. So tan inverse ECN over EAN, we replace and we get the answer for theta as 79.4 degrees. Now the reference direction is this part from the positive x-axis, from this point to this point. This is the reference. So what is this equal to? The whole angle is 90 degrees. If I say 90 minus theta, I will have this part left. So 90 minus theta, or 90 minus 79.4, and we get 10.62 degrees from the positive x front. This is the direction of E net. Again, in this system we have two negatively charged objects, A and C, and we have to find the resultant or the net electric field at point N. So we cover QC, EAN should point to the left because it should converge towards A since A is negatively charged. Then we cover A. ECN should point towards C because C is negatively charged as well, and the electric field converges towards negative charges. Now the calculations, KCQA over RAN squared, we replace the values, also the conversions, and we get the answer. Same thing for ECM. We replace to get the answer. Now we draw the imaginary lines, we draw E net. Again, the diagonals are equal, this diagonal and this one, they are equal. So E net is square root of EAN squared plus ECN squared. We replace and we find the final answer for the magnitude of E net. Now we have to find the direction. Okay. If we try to extend the x-axis like this, then the direction of this vector starts from the positive x front to the vector itself. This is the direction. So I have to find an angle. If I consider this angle theta, then the direction will be this angle, which is 90 degrees from this point to this point. So it will be from this point to this point 90 degrees plus the angle theta, which is this one. So theta equals tan inverse opposite over adjacent. This is the angle. Its opposite is this horizontal dashed line, which is the same magnitude as EAN, and the adjacent is ECN. We replace and we find theta as 30.65. Now the direction will be 90 plus 30.65, which is 120.65 degrees from the positive x front. In this system we have a positive charge and a negative charge. QA is negative, QB is positive, and we have to find the net or the resultant electric field at point P. We follow the same steps. First we draw the direction of the electric field, so we cover QB. For QA, which is a negatively charged object, the electric field converges towards A, so it goes this way. This is EAP. For QB, which is positively charged, the electric field diverges away from B, so it goes this way at point P. Now we do the calculations. EAP is KCQA over RAP squared. We replace the values. For EBP, same thing, KCQB over RBP squared. We find the answer. For E net, again we draw the imaginary lines. This is E net, which is equal in length or magnitude to the other diagonal. So E net equals EAP squared plus EBP squared. We replace their values to find the magnitude of the resultant electric field, or E net. Now for the direction, we have to choose an angle theta. I chose this one. So let's draw the direction. As we said before, the direction goes from the positive x front to the vector. So it starts from this point, you go counterclockwise to the vector itself. So the measure of this angle will be, or the direction will be, from this point to this point we have 270 plus theta plus the angle. So for this angle, the opposite is this dashed line, which is EBP, and the adjacent is EAP. We replace and we find theta as 48.37 degrees. Now for the direction, as we said, it will be 270 plus 48.37, and we get the answer as 318.37 degrees from the positive x front. In this system, we have two positively charged objects, A and C, QA and QC. Both are positive, and we have to find the resultant or the net electric field at point P. We follow the same steps. First, we have to draw the field vectors for each charged object. I will cover C. QA is positive. Its electric field points away from A or diverges from A at all points. So at point P, it will be pointing away from A. So this is EAP. Then for QC, we cover QA. QC, the same thing. The electric field of C points away at all points. So at point P, it should be diverging away from C in this direction. This is ECP. Now we do the calculations. EAP is KCQA over RAP squared. We replace to find the answer. ECP is KCQC over CP squared. We replace the values. Always remember to convert. Do not forget to convert. And we find the answer for ECP. Now to find the magnitude of the resultant electric field, we continue drawing the shape and we draw E net this way. Again, the diagonal E net is equal to the other diagonal, so the magnitude is the same. So E net is equal to EAP squared plus ECP squared. We replace the values or the magnitudes of each to find the resultant electric field as 3923 newtons per coulombs. Now to find the direction, we have to find an angle theta that is equal to the inverse opposite over adjacent. We choose an angle. I chose this one. So we check the opposite to this angle, which is this vertical dashed line, which is the same as EAP, and the adjacent is this one, which is ECP. We replace and we find the angle. Now this is an angle, but the direction is from the positive x front counterclockwise to the vector. So now if we check this angle from this point to ECP, it is 180. So 180, if I remove theta, I will be left with the reference angle or the direction. So the direction in this case is 180 minus theta. So 180 minus 30.65 degrees, we get 149.35 degrees from the positive x front. Okay, in this system we have two negatively charged objects and the point P. We follow the same method. Now we covered one of the charges. Now the electric field created by A at P should point towards A because A is negative. The electric field converges. For B, the electric field EBP should point towards B because B is negative, so the electric field converges as well. Then we do the calculations. EAP KC QA over RAP squared, we replace the values and we get the answer as 2000 newtons per coulombs. Then for EBP KC QB over RBP squared, we replace and we get the answer also in newtons per coulombs. Now we have to find E net. So if we draw the imaginary lines to continue the rectangular shape, this diagonal is E net, which is equal in length or magnitude to the other diagonal. So E net is equal to EAP squared plus EBP squared. We replace their magnitudes and we find the magnitude of the resultant or the net electric field. Now next step, we have to find the direction. The direction, we find an angle theta equals tan inverse opposite over adjacent. In this case I chose this angle. So the opposite is EAP, the adjacent is EBP. We find the answer is 30.65. Now for the direction is from the positive axis front to the vector, so it's this part which is theta. In this case is the same as theta, so it is 0 plus 30.65 and we get 30.65 degrees from the positive x front.